So let's see some examples of Rolle's theorem here. One of these should be on the test. I'm not trying to make it difficult for you. What I'm trying to do is let you see an example of Rolle's theorem and show that you can meet the conditions, okay? So it says find two x-intercepts of f of x equals x squared minus 3x plus 2 and show that f prime of x equals 0 at some point between these two x-intercepts. So what is an x-intercept? An x-intercept is where your function's equal to 0. So what it's saying is if we have two places where this function's equal to 0, or their y values are the same. And if there's two places where the y values are the same and the function's continuous and differentiable, then there has to be a point where the derivative is equal to 0. What they're really getting at here is there has to be a critical number between the two x-intercepts. There has to be. So let's figure this out here. How do you find x-intercepts? So let's do that first. So first we're going to find the x-intercepts. Find the x-intercepts. To find those x-intercepts, all you do is set the function equal to 0. You set f of x equal to 0. So let's do that. Let's take the function, which is x squared minus 3x plus 2. Let's set it equal to 0. What can we do? Well, let's try factoring two numbers that multiply to be 2 and add to be negative 3. I think those numbers would be x equals negative 2 and x equals negative 1. So I'm going to double check this real quick. I'd have x squared minus x minus 2x, which is minus 3x. Minus 2 times a negative 1 would be a plus 2, so that seems right to me. I set each one of those values equal to 0, x minus 2 equal to 0, and x minus 1 equal to 0. Add 2 to both sides would give me x equals 2. Add 1 to both sides would give me x equals 1. So these right here are x-intercepts. And notice, they give me the points 2, 0, and 1, 0. What I really want to emphasize is they have the same y value. They have the same y value, or function value, okay? So let's apply Rolle's theorem. What's the first thing we need to state? The first thing we need to do is look at the function. The function is a quadratic function, which is a polynomial function, and all polynomials are continuous. So the first thing we need to say is f of x is continuous on the closed interval between the x values, which would be 1 to 2, right? So on the closed interval, 1 to 2. 1 and 2 being the x values that we just saw. The second thing we need to do is state that it's differentiable, and we need to do this. F of x is differentiable on the open interval, 1 to 2. So state that it's continuous on the closed, it's differentiable on the open interval. You must state this. The third thing you need to do is say f of 1 equals f of 2, which are both equal to 0. So we've shown that it's continuous on the closed interval, it's differentiable on the open interval, and the endpoints, the y values of the endpoints, are the same. So, by Rolle's theorem, there exists a point on the open interval 1 to 2 where f prime of x equals 0. I'll just write it up there, okay? That is what Rolle's theorem tells us. It says there has to exist a point where it's 0. We have now used Rolle's theorem, and that is all Rolle's theorem does. Is Rolle's theorem says there has to be a point where the derivative is equal to 0. In other words, there has to be a critical value in this interval. The second part of this problem says we actually need to find the point. This is not Rolle's theorem. Rolle's theorem only shows the existence of a point. So now we want to find it. So let's consider f prime of x. F prime of x, the derivative of x squared is 2x. The derivative of minus 3x is minus 3. Derivative of 2 is 0. So the derivative of x squared minus 3x plus 2 would be 2x minus 3. we're saying when the derivative is equal to 0, add 3 to both sides, you'd have 2x equals 3, divide both sides by 2, and you'd have x equals 3/2, which is 1.5. Notice this value right here is in that given interval 1 to 2. So Rolle's theorem said this point must exist. There must be a critical value between here. And we just found it. We found it at an x value of 1.5. Okay? So 1.5 is potentially, not guaranteed, but potentially a maximum or a minimum point. So again, very, very, very important here. The first thing you have to do to get this right, to get credit for this problem, is state that it's continuous on the closed interval. Second thing, state that it's differentiable on the open. Third one, look at the endpoints and say the y value is the same. Conclude from Rolle's theorem that the point must exist, and then find the point. Again, part 4 is not Rolle's theorem. Part 4 is us doing math. Rolle's theorem merely tells us the existence of a point. Okay. Example 2, let's try it again. It says let f of x equal x to the fourth minus 2x squared. Find all values c on the interval -2 to 2 such that f prime of c equals 0. This is an illustration of Rolle's theorem. So we use Rolle's theorem to say the point must exist, but then we actually have to calculate it. On the previous test with the intermediate value theorem, most of you just calculated it. That's not the point of this problem. The point of this problem is to evaluate Rolle's theorem. So the first thing we need to do, again, every time we use Rolle's theorem, is state, look, this is a polynomial function, x to the fourth minus 2x squared, which is continuous everywhere. So let's say that f of x is continuous on the closed interval -2 to 2. It's always continuous on the closed interval. The second thing we need to state is f of x is differentiable on the open interval -2 to 2. That's because it's a polynomial function, which are differentiable everywhere. It's not like absolute value of x where you have a cusp or anything like that. The third thing we need to do is evaluate the function at the endpoints. So let's look at f of -2, which would be -2 to the fourth minus 2 times -2 squared. Let's go ahead and figure out what that is. -2 squared is 4 times -2 would be -8. So just put the whole thing into your calculator, please. Make sure you use parentheses. I'm getting a value of 8, a y value of 8, and I need to plug in the other endpoint, so f of 2. So this would be 2 to the fourth minus 2 times 2 squared. And once I put that into my calculator, 2 to the fourth minus 2 times 2 squared, I'm also getting 8. So what's important about this? These y values are the same. Okay, continuous on the closed interval, differentiable on the open interval, and our endpoints have the same y value. That means, by Rolle's theorem, and I need to see this sentence, by Rolle's theorem, there exists an x equal to c in the open interval, -2 to 2, such that f prime of c equals 0. There's at least one point in the open interval, one number between -2 and 2, where the derivative is equal to 0. That is Rolle's theorem. We have proven the existence of a point. Now we're going to go on to step 4, and we're going to find the dang point. Again, this is just the end of the problem. This is not the guts of the problem. The guts of the problem is Rolle's theorem, so make sure you have those first 3 steps. So let's find the derivative. The derivative of x to the fourth is 4x cubed, and the derivative of minus 2x squared would be minus 4x. We want to set that equal to 0. I'm going to factor out a 4x from both of them, because that's what they have in common. 4x cubed divided by 4x would be x squared, and negative 4x divided by 4x would be minus 1. I set those equal to 0, and I'd have 4x equals 0, which gives me x equals 0. I'd have x squared minus 1 equals 0, which would give me x squared equals 1. Remember, whenever you take the square root, you have to remember plus or minus, so I'd actually have x equals -1 and +1. So it looks to me like I have 3 points in the interval between negative 2 and 2 where the derivative is equal to 0. So it says f prime of c equals 0 when x equals, well, if I did them in order, it would be negative 1, 0, and 1. 3 points where the derivative is 0. Again, Rolle's theorem just says there has to exist 1 point. We were actually able to find 3 points in this instance. So all 3 of those points would be critical values and potential maximums and minimums.